Bivariate data, two sets of quantitative data. Scatterplots, a graph that relates two groups of data. Scatterplots represent bivariate data. Association/correlation, the relationship between two variables that are statistically dependent. Strong versus weak association. A strong association, the data points will cluster in a predictable pattern. For a weak association, the data points cluster loosely in a pattern that is less predictable. Here we want to draw examples of strong positive, weak positive, no association, strong negative, and weak negative associations. For a strong positive, we should see a tight grouping of points where we can get a predictable trend line or understanding pattern for how the data is going. Weak positive, we understand that the trend is increasing, but it is more difficult to group or draw a trend line that would encompass all of the points. No association, just a random splattering of points. Strong negative, you have a grouping of data that shows a trend of decreasing, where weak negative, still able to determine decreasing, but your pattern is more or less unpredictable or more random, but you still get the general sense of a decreasing nature. Trend line, a line that models the relationship between two variables in a scatter plot. The line of best fit is the trend line that best models the relationship. So a line of best fit is a trend line, but it is the one that best models the relationship. Residuals, the prediction error calculated by subtracting the predicted value from the actual value. We're looking at these two examples for lines A and line B. Which line is the better fit for the data, and explain your reasoning? For me, I have to say this is line A. Line A minimizes residuals, and it just fits more closely to the majority of the data points. Here we want to talk about what the slope and y-intercept represent in terms of each of the data that is modeled. For line A, your y-intercept is about 140 here, and that's representing the 140 beats per minute of your heart rate at birth. The slope for this line is representing the change in your heart rate over your age. So in this case, it's a decrease in heart rate over your age and years. So as you get older, your heart rate decreases. For the second example, we've got a y-intercept here at about 7.5. And this y-intercept represents the $7.50 initial pay for starting the job with no experience. Where your slope in this case, you see an increase in pay or hourly wage over months worked. In this example, you'll see that your y-intercept is right here at 1,000, and it's talking about cost of vacation in terms of days on vacation. So your y-intercept in this case, you're looking at $1,000 is your initial cost before your vacation starts. So this would be things like tickets and like hotel reservations. Then your slope in this case, well, you're seeing an increase. Well, you're seeing an increase in total cost. And it increases as the length of your stay on vacation. So you see an increase in cost in reference to the length of or the number of days that you're on vacation. So here we're talking about correlation and causation. Correlation talks about the relationship between two sets of data, where causation occurs when the change in one quantity causes a change in the other, so one causes the other. Just because two variables are strongly correlated, we cannot assume that one causes the other. So our first example, the height of a plant increases as the amount of sunlight it receives. Well, plants need sunlight, so this is definitely correlated. We know the two go together. Plants and sunlight just go hand in hand. Hand in hand, it's science. Does the increase in sunlight cause a plant to grow? Yes, it does. So that's causation. So here we have yes and yes. For question 2, a survey of a class shows the students who get lower grades spend more time sleeping each week. Are these items correlated? Well, they ran a survey, so there is some kind of correlation there, so we'll say yes here. But does sleeping more make you have lower grades? Not necessarily, so there's no causation here. You can't prove that sleeping more means you get worse grades. Correlation coefficient. A positive correlation is when your x increases, your y increases, and you have a positive slope. Strong positive correlation, dots close to the line of best fit, and your correlation coefficient, or your R value, will be between 0.7 and 1. Weak positive correlation, dots not close to the line of best fit, and your R value or correlation coefficient is between 0.3 and 0.7. Negative correlation is when x increases and y decreases, or you have a negative slope. Strong negative correlation, dots close to the line of best fit, but your correlation coefficient is between negative 0.7 and negative 1. Weak negative correlation, dots are not close to the line of best fit, and your correlation coefficient is closer to negative 0.3 and negative 0.7. No correlation, you see no pattern, and your R value is close to 0. The closer to 1 or negative 1 your value is for your correlation coefficient, the better or more predictable the pattern is for your scatter plot, and the easier it's going to be to draw a trend or line or a line of best fit. Negative correlation coefficients mean your line has a negative slope. Positive means it has a positive slope. So let's see. We've got two different graphs here, and we're trying to determine which of the choices for correlation coefficient best fits each data. If I were to draw a line of best fit here, I'd have something like this for the first one, and most of my points are relatively close to this line. So if I had to guess, I would say I know the line's increasing, so I know these two are out. 0.6 would be a weak correlation. It's not really weak. I think it's closer to the strong, so I'm going to choose 0.9. It's not perfect, but it is pretty close. Question 2, if I wanted to draw a line of best fit, it'd be something like this. Well, something closer to, let's say, that. It's a decreasing slope, so I know the positive values are out, but I know that the points are far away from the line of best fit. They're not great. There's some way over here, and there's some above and below it. So it's not as close as we'd like it. So I'd say negative 0.9 is out, and so the best option would be C, negative 0.6.